Testing IoT devices can be very tricky. There are sleep periods where the power is really low, and then it goes into an awake mode where it's doing something and there's a big power spike. And trying to see both the power consumption at the sleep mode and the power consumption when it's awake and working causes issues. So I'm here with Alan Wadsworth, a business development engineer for the Power products, to talk through how to actually measure IoT devices in that situation. Talk me through what you've brought in today.
Okay, so today I brought the N6705C DC Power Device Analyzer, and it's got a variety of different modules and features available for it. In this particular case, I'm using the SMU modules, source measure units, because they have some very nice features I'll get into in a minute about seamless measurement ranging. But this product is very popular. It has a scope feature, a data log feature. You can data log things for long time periods. And it's very good at looking at IoT devices, as you had just mentioned, yeah.
So you have a sample IoT device, which is going to have a low power range and a high power range.
Correct, yes.
This is both powering it, it's sourcing power, and it's measuring, hence the source measure unit configuration. Can you talk me through kind of what waveforms we expect to see coming out of this device?
Right, yeah. So I actually have two modules in here. So the first is a power module. It's the basic power module that's providing 9-volt input to my device here. And then I've got the SMU module connected to the output. It's got applying 5 volts to the output. And you're going to expect to see some waveforms. You're going to see, essentially it looks like 0 amps of current. And then you're going to see a spike that's about 120 milliamps. And as I'll show you in a minute, when you try to go down and look at the low levels of current, you're going to see a bunch of noise.
So we'll be able to see how much power the device is consuming, and then we'll get a snapshot of the current output in those different states.
Correct, yeah. And we're going to be using the scope mode for this, but as I like to point out, you can also do this in the data log mode. So if I wanted to look at this device for minutes, hours, even days, I could take a data log of that, and I'll actually see both the high and low levels of current.
So great for characterization. Let's take a look. Right now we're in meter mode. Can you put us into scope mode?
Yes, I can. So I'm going to go into scope view. I put us into scope mode. I put us into run. So this is actually making an active measurement on my device right now. So you can see on the instrument here, the peak is about 120 milliamps. Now the question is, what happens when I try to go down and look at the low level of current, which kind of looks like it's 0, but we'll see it's not really 0 when I go down. So now I'm basically going down to a lower scale. Let me get down to 200 nanoamp scale. So now we're at a 200 nanoamp scale, and you can see that all I see is a lot of noise. And unfortunately, that's because I'm in a 3 amp range for measurement, and so it just doesn't have the resolution for the low current measurement. So basically a lot of noise.
So if I'm trying to measure and characterize the sleep mode of this device, that sort of waveform not going to help me a whole lot.
Exactly. And this is not what you want to see, right? So the beauty of the seamless measurement ranging feature of the product is that it actually measures multiple ranges at once. So it's going to measure both high and low, and I can actually see both the high and the low at the same time without having to change ranges.
All right, so do you want to set us up into seamless mode?
Yes, so now I'm going to change over to seamless mode. So what I have to do is I'm going to stop this temporarily, menu, and I have to go down to scope mode. And I'm going to scope properties. You can see that I'm currently in the 3 amp measurement range. And so you can see that the options I have are 3 amps, 100 milliamps. So there's lower measurement ranges, but again, I have a 120 milliamp peak, so I can't be in the 100 milliamp range because I'll get an error message. So I have to be in the 3 amp range. I can't see the low currents, but I can go and put this into an auto mode. So we're now in auto measurement ranging mode, and I'm now going to go back to the scope view, and I'm going to restart the waveform.
Whoa.
Isn't that impressive?
That looks so much better.
Doesn't it? So now suddenly I can see the high and the low. And if I go back and change the scale, I can still see my peaks. So I can see both the high and the low at the same time. And also, again, if I wanted to data log this, I have this on my data log so that I can actually go in and look at this. And this, again, you can data log for basically as long as you want.
So then you could capture days, weeks, months of data. Maybe you have something that wakes up once a week to send a temperature report or something.
Exactly, yeah. And no problem doing any of that. And Again, this seamless ranging is pretty nice. It's unique to Keysight. It's a patented feature, and it's supported on a variety of different SMU products that we have as well, not just this. So it's really great for these kinds of applications.
All right, thanks, Alan.
All right, thank you.
Learn more at keysight.com/find/DC Power Analyzer.